So we just finished looking at determining the maximum volume that we can get of a container for a given surface area. Okay? So what we want to do right now is, if we've been given the opposite situation, okay, finding the minimum for a given surface area. So if we're told we need a container that will hold a certain volume, and we need to minimize the surface area so that we can minimize how much material we use. Okay? So in this case, a manufacturer is designing a cylindrical bottle. Cylindrical just means it's a cylinder that can hold 1 liter, which, remember, is 1,000 centimeters cubed of shampoo. What type of cylinder will require the least amount of plastic? Least, so we're getting a minimum value, or we should get a minimum value. Okay? So we did a rectangular prism last time, so I wanted to show you something a little bit different. Okay? This is finding a minimum for a cylinder. So this picture should look familiar if you watch the video on where the area and perimeter formula, circumference formulas come from for a cylinder, for a circle. Okay. So hopefully this net looks familiar, where this rectangle comes from. Just if we were to unwrap, if we were to make a cut down the side and unwrap it, you would get this big rectangle in the middle. Okay. So what we need to do is find a way to relate the volume that we need to the minimum surface area. So what we're going to try and do is we're going to find a relationship, an equation, relating the radius to the surface area. Okay. So that's given that, I'll move this a little bit so we can see. Okay, there. So we know that this length is 2 pi times the radius, or we could always call that 2 times the diameter, okay, but we're going to be using radius a lot. 2 pi r is the formula for the circumference. Okay. So this distance is 2 pi r, and this distance is 2 pi r. So remember, the surface area for that circle, okay, for this circle is pi r squared. But we have 1 circle, 2 circles. So this is pi r squared, the area. So the surface area is definitely going to be made up of 2 circles. So 2 of these pi r squareds. Okay, so this part is the circles. But then we need to add the area of the rectangle for the total surface area. So the rectangle is going to be 2 pi r times h. So we need to add 2 pi r h. Now once again, we're in a similar situation that we were last time, in that we want to relate surface area to radius. We can find the radius, but we still have this h in our formula. But remember, we have our volume formula. The volume of a cylinder is the area of the base, which is pi r squared, times the height. And in this question, we have a required volume of 1,000 centimeters cubed. So we're going to want to use the number 1,000 here, not the number 1. Because if we have 1 liter here, and this is in centimeters, then our units won't work out. Okay? So if we multiply these two together, r squared, and multiply it by an h, we're going to end up with centimeters cubed. So we put the 1,000 in there. And then we can finish writing our formula. Now we can rearrange this for h. Divide both sides by pi r squared to get rid of that. I say get rid of it, but it really doesn't go anywhere. It just goes to the other side of the equal sign. Okay? So now we've got 1,000 divided by pi r squared is h. So we can put that back into our formula. Times 1,000 divided by pi r squared. Hopefully that's not too small. Okay. Now we can do some simplifying. Okay. Whoop, should be a bracket there. We can always do some simplifying. So this is going to be, this is just 2 pi r squared, and this is going to now be 2,000, 2 times 1,000 pi r, all divided by pi r squared. So this part can be simplified. Okay, the pi's cancel out. The r and the square cancel, one of the r's cancels out, and what we're left with is 2,000 divided by r. And that is going to be my simplified surface area to radius formula. So the next step, okay, once again, there really is no clear way to determine the maximum for this. Okay, you can do it for, say, a quadratic formula, but since we've got an r on the bottom, it's going to be kind of challenging to figure out the minimum that we need for this r, the minimum value. So we are going to use, once again, we're going to use graphing technology. We're going to use a graphing calculator. So I'm going to switch over to my graphing calculator and show you how to do that.